Going back to the idea that letrec could be implemented in the parser, again, this is the old way of doing things, but there's a different kind of conversion that the parser might make. It might take something like this letrec version that implements the factorial function, and if we had mutable variables in our language, it could parse it the same as this form, where we let factorial be some dummy value like 42, and then inside of a begin, we change factorial's value so that it refers to a function. And the reason this helps is because now this function that we wrote on the right-hand side of the assignment is inside the body of the let. It can refer to the factorial variable, right? And we have just assigned to that variable so that it refers back to the function that's referring to the variable. So this factorial of 10 will work as expected. Now this approach of expanding letrec to a mutable variable pattern, that only works if we have mutable variables on assignment and bow. And we explored that for a while, but we've taken mutable variables back out. And since we understand state, we can use it at the Shplait level to implement letrec, and then we know how letrec works with state in general without having to add state back to Mo. So that's what we're going to try next. In other words, we're going to change our type of binding in a different way. Instead of the value having immediate value or a function that returns a value, we're going to have a binding have a boxed value inside of it. This is boxes, so that's where the state part comes in. And along those lines, we'll change the lookup function now to unbox when it's getting the value out of a binding. Our interpreter now, in its letrec E case with a name right-hand side and body, it's eventually going to interpret the right-hand side and the body in some environment, but we don't want the environment that we were given it for interp. We want some new environment that includes a binding for name for both the right-hand side and the body. So we're going to create a new environment that extends the current environment with a binding for n, and the new part here is that we are putting a box inside that binding. Inside the box, we can put a dummy value like 42, say. This box is the one I need to update later after I've interpreted the right-hand side, so let's give that box a name instead of putting it in line there. So I'll let B be the box that initially has 42. I will build up an environment that maps the name to that box, and then I will interpret the right-hand side in that environment. We'll get a value back from that interp, and that is the value that I want to replace the 42 in the box. So I'm going to have a set box B on the result of that interpret, and after we do that, then the environment has the right value in it to interpret the body, and so we will be all done. The letrec interpreter has all of that code in place, and if we try running this with our factorial example from before, it still works, as does something like letrec equals 10.